Today I'm going to be talking about using the property of trapezoids, and this is Chapter 7, Section 5. So first off, let's look at this trapezoid, okay? This is an isosceles trapezoid, and if the legs of a trapezoid are congruent, these are the legs, we've done them in green, if they're congruent, then the trapezoid is an isosceles trapezoid. And the other properties of this is that both pairs of the base angle are congruent. Well, first of all, these bases are parallel. Okay, so the bases are the parallel lines. And so on the parallel lines, we have base angles. This base angle is congruent to this base angle. And then let's do a different color. Let's try purple. And then this base angle is congruent to this base angle. So those are congruent to each other. Okay. Next up, the diagonals are congruent and the legs are congruent. So we're going to use these different pieces to solve for some missing sides and angles and variables in these trapezoids. So it says PQRS is an isosceles trapezoid. Find the measures of Q, P, and R. Well, if we look at this, S is 50 degrees, so that means its matching base angle is also 50 degrees. Now, if we want to find P and Q, these angles right here are consecutive or supplementary. So we can say 180 minus 50, and we get 130. So this is 130, and its corresponding base angle is 130. So what we're going to do is we're going to look at the one on the left. We have to be careful because remember the base angles run along the parallel lines. So even if I turn it, we can make sure we put the correct measurement. The corresponding base angle for 35 degrees is P, which is also 35 degrees. To find the other angles, we do 180 minus 35, and we get 145. For the other two base angles. All right, what's next is that PQRS is an isosceles trapezoid. Solve for X, Y, and Z. So we're going to use all of our pieces to solve. Let's look at Z first. I think that's the easiest one. Well, we know this is an isosceles trapezoid, so both of these are equal to each other. So we can say that 5Z plus 25 is equal to 7Z. We can now solve. Subtract the 5Z. 25 is equal to 2z, divide by 2, z is 12.5. Okay, let's do x. X is at a base angle, and it's congruent to its corresponding base angle. So we can set 2x plus 10 equal to 55. Distribute. Subtract. And divide. So x will equal 17.5. And now y is congruent to this angle over here. So we can say 180 minus 55. And we get 125, so y is equal to 125. There we go. So we can use all of our pieces to solve for those variables. Next up, we have another piece of the trapezoid. It's what is called a midsegment. Okay, and a midsegment connects the two midpoints of the legs. It's parallel to each of the bases. All of these are parallel. And we also have a midsegment formula to find the value of the midsegment, which is 1/2 base 1 plus base 2. So we're going to use all these pieces to solve. First up, I need to find the measure of FED. FED is right here. We need to find that measure. Well, to find that measure, we can use our knowledge about parallel lines. Parallel lines, which we can use this one and this one, we can draw a transversal, give us congruent angles. These are our corresponding congruent angles. So that means the measure of FED is 73 degrees. So those parallel lines give us our corresponding congruent angles. So same thing down here. That would make y equal to 25 degrees because we have our parallel lines, our transversal, and that gives us our congruent angles. So we can use those parallel lines to our advantage. Next up, we're looking at the midsegment. We're finding the midsegment. So it says find EF. Wherever we're finding something, we can put an X. And we're going to write down the midsegment formula. We can say the midsegment is equal to 1/2 base 1 plus base 2. And we're going to just fill in and solve. So the midsegment is our X. 1/2 base 1 is 28. Base 2 is 13. So we can combine 28 and 13, which is 41. And then we take half of that, which is 20.5. So we found our midsegment. Now be very careful when setting up the next one. We're finding DC for this one. So I'm going to put an X at DC. I'm going to write down my midsegment formula. Midsegment equals 1/2 base 1 plus base 2. But this time they give us the midsegment, so I'm going to plug in 8 for the midsegment, which equals 1/2, and our base 1 is X, and our base 2 is 15. Now it could be 15 plus X, it doesn't matter. We're adding, so you can put it either way, either order. So now what I'm going to do is I'm going to get rid of this half first. I'm going to get rid of this fraction. By doing that, I multiply by 2 on both sides. So I get 16 equals, and that cancels X plus 15. I always like to get rid of that fraction first because I don't have to deal with any more fractions or decimals after that. Let's try one with a little bit of algebra. So let's look at our next one. So same thing here. We're solving for X, and I give you a midsegment, so we can write down our midsegment formula. Midsegment equals 1/2 base 1 plus base 2. So now we're just going to fill in our information. Our midsegment is 55. 1/2 base 1, we can say X plus 10, or 2X plus 15, plus 2X plus 15. The first thing I'm going to do is get rid of this fraction. I'm going to multiply by 2. So I get 110 equals, that cancels X plus 10 plus 2X plus 15. I'm going to combine my like terms. So I get 110 equals 3X plus 25. Subtract the 25. We get 85 equals 3X. Divide by 3. And we get about 28.3 for X.